Section 1.3 is about solving equations, and this is going to start out and it's going to seem very easy to you. And I've got some questions that'll kind of make it seem a little unusual, or you might think, why is he asking me those questions? But I do have a really important point later on. But I'm pretty sure you know how to solve an equation like this for a particular variable, in this case z. I do want to ask you a question. Why would I know that this is a variable term? And the reason I would know that's a variable term is because it has the variable that I'm interested in. In this case, it's z. So we call that a variable term, just like we would call this a variable term. But these that don't have variable terms would be called constant terms. Now, the reason that I'm identifying them as variable terms or constant terms is because we know from our pre-algebra and Algebra 1 days that you put the variables on one side, you put the constants on the other, and then you divide if necessary. Okay, so in this case, I would probably be moving this over to this side by subtraction. All right, that's going to get rid of that. And I would be moving the 12 over to the other side, so I would subtract that. So I'd get rid of that. Leaving me with 3z equals negative 33. And many of you would do the division and get negative 11. Okay, not a very difficult problem to solve. Many of you would be able to do that very quickly, very easily, and have no problem with it. So our examples are going to get a little bit more difficult, but not terrible, at least not for this next one. And then we'll switch gears into something that will be more challenging. So I've got this problem which involves the distributive property, right? 6t minus 12 and 18 minus 4t. Well, now it looks a lot like the last one. Okay, so we really only added one step to the whole process. And now you push the variable terms to one side. Obviously, you're adding the 4t. And you'll put the constant terms on the other side. Obviously, you're adding the 12. And then you can divide out the 10, giving me a t value of 3. And I'm pretty sure most of you would get that example without any questions, not having any difficulty. It's when we get to example 3 that things get a little bit more hectic. But before we get to example 3, I want to ask you, no. We could do example 3. It's example 4 where I've got to give you a preview example or a preview idea of what's going on before we get into that one. In example 3, we start off with the good old area formula for a trapezoid. Okay, and I might ask you to solve for h. Well, in solving for h, we want to get rid of the 1/2. So the first thing we want to do is multiply both sides by 2. I know that some of you would want to say divide by 1/2, which is true, that would work, but division is the same as multiplying by the reciprocal. And since we don't want a fraction within a fraction, kind of like an inception idea, a dream within a dream within a dream, where nobody knows what's going on. Okay, we would like to just multiply by 2 on both sides. Well, try your hardest to resist the idea of distributing. A lot of kids want to distribute the h right here. That is not what we want to do. Okay, because it actually creates more work for yourself if you do that. So, in order to take care of this problem, we are actually going to do division. I see that h is being multiplied by something, so we are going to divide by that entire thing. Now, if that was a 5, like this said 5h, all of you would say, divide by 5. Well, so all we're doing is taking this and dividing by this quantity. Now, I hope that you're watching this at home, because a lot of times kids take this idea and they say, okay, yeah, 5. This is a completely separate thought, but it relates back to this question. 5 divided by 5, oh yeah, that cancels out. X divided by x, oh, that cancels out. That is not what's going on here. You cannot cancel out the b sub 1's. You cannot cancel out the b sub 2's. We are canceling out the whole factor b1 plus b2, or base 1 plus base 2. You can't simply, that's like saying, a lot of kids like to say this, 8 plus 5 over 5. Now we know that's 13 over 5. We know that's 2.6 if we would work that on a calculator. Some kids want to do that. No, we cannot do that. They want to say that that's equal to 8. I know in the background you might be hearing what sounds like dental work. That would be the custodial staff drilling on the walls. So it might sound a little weird here while we're recording this video. So anyway, base 1 plus base 2 cancels with base 1 plus base 2 because those are the factors. It's not the base 1s and the base 2s separately. So h is equal to 2a over base 1 plus base 2. Now we could take that exact same question, a equals 1/2 h base 1 plus base 2, and we could solve for a different variable. Suppose this time I ask you to solve for base 1. Well, we would start out same way. We would multiply by 2, right? That gets rid of the half. This time, though, instead of dividing by the sum of base 1 and base 2, we're actually going to divide by h, getting rid of the height and moving it to the other side. So now we have 2a over h equals base 1 plus base 2. I'm pretty sure most of you know what to do after this because you're trying to get base 1 by itself. You're going to move that over by subtracting. So 2a over h minus base 2 equals base 1. Now, I'm going to be asking you about things like restrictions. A restriction is something that a variable cannot equal, or it changes, it limits, I should say, limits the possibilities for the variables. In this particular example, h is a denominator, and we all know that, I don't know if you hear the helicopter going over, man, this video's really interesting. My goodness, what's going to happen next? So, the restrictions, h cannot be equal to 0. We know that every denominator in the universe has a problem with 0. You cannot divide anything by 0. I hope you understand that, because I'm going to ask you, anytime you see in a problem any kind of denominator, which is a variable, you have to state that that cannot equal 0. Sometimes our restrictions are going to be at the beginning of the problem, sometimes they're going to be at the end of the problem, sometimes they'll be at both. We'll move into an example that we'll use for example 3. I don't like fractions. Most of you don't like fractions either. So in these particular situations, we want to get rid of the fraction by doing multiplication. So what number do I have to multiply everything by? Sorry for yawning. A little bit worn out. 6. That's true. Everybody should know that it's really 6 over 1. Normally people don't write the over 1 part, but I just want to make sure that when you start multiplying, that you don't change the denominator at all. For instance, when you multiply this times this, it's 6x over 2. But you can also reduce that to 3x. And the next one is 6x over 3, which is 2x. And 6 times 1 is 6. Okay? We'll come back to this problem in a minute, but all I was getting at is this. When you don't know what to multiply through an entire equation by to get rid of the fractions, then the only thing you have as an option is to take the denominators and multiply them together. Most of you would have said 6, and you only find that by multiplying 2 and 3 together. Okay, so in this next example, we have, we'll come back to this one in a second. X over a plus 1 equals x over b. What should I multiply everything by? Well, I don't know. I don't know whether a goes into b or b goes into a. So I'm going to multiply everything by ab. Okay, so I'm multiplying everything. When I multiply this times this, the a's cancel out, leaving me b times x. When I take AB and multiply by 1, which a lot of students forget this one, they just put plus 1 and then they ruin the problem. And then when I multiply this one times this, the b's cancel out, so that gives me AX. Remember I asked you a while back, what's a variable term, what's a constant term? Well, it was pretty easy from the first example to see that a variable term had the letter that you were trying to solve. Well, in this particular example, this is a variable term and this is a variable term because both of them have the x in them. But this one right here is called a constant term because it does not have an x. I know you're telling me, well, they all have variables. Well, I understand that. But since it doesn't have the variable I'm interested in or I'm solving for, it's not called a variable term. It's called a constant term. And we know from our days in algebra that you get the variable terms on the same side. So we're going to have ax minus bx. Let me go back to the previous problem because I think I need to show you what happens after the 3x plus 2x equals 6. I know many of you are going to look at this and say, well, that's 5x. 5x equals 6. But let me show you in slow motion what you did. You guys used the distributive property. Now you're saying, Mr. Staley, how did I use the distributive property? I mean, I just added 3 and 2. I didn't do anything fancy. Well, what you really did in slow motion here is you looked at both terms and you said, what do they have in common? And there was an x in common. So you factored out an x. And when you factored out an x, you found out that it was x parenthesis 3 plus 2. Because what you're left with is 3 plus 2. And that 3 plus 2 turns into 5. So that's how you got your 5x. You factored out what they had in common. Then, of course, you're going to divide by that number 5. Okay, so I see this particular situation here, and I ask myself, what do they have in common? Well, they have x in common, and if I pull that out, I get a minus b. And now x is being multiplied by something, so I can divide to get rid of that, right? Those two things cancel out. So x is equal to ab over a minus b. Now let's take a look at restrictions. There are actually 3 of them. Go back to the beginning. I'll write them over here on the side. I see a denominator there. So a cannot be equal to 0. I see a denominator there. B cannot be equal to 0. I even see one down in my answer that's different than those two. So a minus b cannot be equal to 0. So far, I've got 3 restrictions. Now, you're never going to see it written like this. That's nice. We're really getting the feeling, getting the feelings today. So, bring the b over to the other side. The only way you do that is by adding it. Now you're asking yourself, why in the world would you rewrite that, Mr. Staley? Wasn't it good enough just a minus b does not equal 0? Well, you're never going to see it written like that. Nobody's ever going to write a minus b does not equal 0. You won't see it in the book. You won't see it in on the SAT math. You will see a does not equal b. And I want you to know those two things are the same. Okay? All right. There are 3 story problems that go with this lesson. And 2 of them are what I would consider easy. One of them is more difficult. Oops. In example 5, they said a rectangular dog run is going to be created by a kennel owner, and they have 100 feet of fencing. That 100 feet, that's the equivalent of the perimeter, can't even talk, the perimeter of the fence, or of the fenced-in area. I don't know how wide it is, but it says that the owner wants it to be 5 times as long as it is wide. 5 times as long as it is wide. Boy, that's noisy. So this side is the same as this side, and this side is the same as that side. Try to resist the urge of telling me that there are 4 x's, because my question is going to be, how many x's are there? Well, 5, 1, 5, and 1 make 12 x's. And we know that that's equal to 100 feet. using your handy-dandy machine, you'll come up with 8.3 repeating. What's the value of the length? Well, you're going to take 5 times this amount, and it ends up being 41.6 repeating. I'm sure we can figure that down to the inch, because we know that there are 12 inches in 1 foot. So that shouldn't be too hard. So that's a pretty straightforward problem. Example 6 isn't too bad. We have a triangle, and the ratio of the sides is 3 to 4 to 5. What this really means is there is some mysterious multiplier out there, which when you multiply it to all 3 sides gives you the values of those sides. So if x was a 1, that would be 3, 4, 5. If x is 2, that's 6, 8, 10. But we need to figure out what that multiplier is. So we've got 3x, 4x, and 5x. And we know that the perimeter, according to this question, is 18. Well, over here we have 12 x's. And so we are able to easily calculate this mysterious multiplier to be 1.5. And if I know that, then I can figure out 3x, 4x, and 5x. Oh. Something like that. Now if I go back to the last question, the last question never talked about a ratio, but I could easily see that they have a common multiplier. So what's the ratio of the length to the width? Well, hopefully you would say 5 to 1. So they could have said the length is 5 times the width. That would give me the same idea. Example 7 is the more difficult question. So we need to make sure we go through this one and make sure you understand it. First of all, everybody needs to make sure they know the dirt formula. Distance equals rate times time. Now we called it the dirt formula for obvious reasons. Just because it kind of looked like dirt. So this particular problem says an unidentified plane is traveling towards us at 700 miles per hour. Now we see this plane. Once we've spotted it, it is a total of 5,000 miles away. 15 minutes after we spot it, we get a plane up in the air, and it's going to our unidentified target to find out who and what it is. Now I'm pretty sure because they're traveling different times and different speeds that they're going to have different distances. This distance is not going to be the same as that distance. But when I add those two distances together, I better get 5,000. So distance 1 is going to be how far we've traveled with this plane. It's got a rate of 700 miles per hour, but its time we don't know. So we'll call it t. So 700t is actually a distance for the first plane. Distance 2 is 800, the rate, times the time. Well, don't do time in minutes, do time in hours. So this would be t minus. Don't put a 15 in there because we don't mean 15 hours. So that 15 minutes is a quarter of an hour. And we know that distance 1 plus distance 2 is the same thing as 5,000 miles. And now we need to distribute and add like terms and put everything on the different sides and divide. Okay, so now I distributed my 800. Add my 200 to the other side and add my t's together, and I end up with 1500 t equals 5200. So when I divide my 1500, I find out that t is equal to 3.46 repeating. My first instinct is to say that that's a good answer, but that is the amount of time that it took the unidentified plane to travel. The question in this problem is, how long did it take the interceptor to reach the approaching plane? So in all reality, I would need to subtract a quarter if I want the real answer. So a rounded version of it might look like that. 3.22 hours. Okay, we'll see you in class.